Complex ions. These are things that some students find difficult, especially when they have to use them to make compounds out of them. But really it's not that hard. It's like instead of showing the group of atoms that act together, you show just one thing. So you can put it in as X and then substitute it as the last bit. But really, it's no different to what we would do for an element when we're writing a compound, and we just think about what's going on. So, complex ions, what are they? They're basically groups of atoms that are bonded together to form an ion. And they're quite common, and we actually find them in the earth, in salt water, and in lots of other things. So they're very, very naturally occurring. A lot of our elements that make up the Earth's surface are actually based upon complex ions. Now, when we are looking at them, we find that they can be metals or non-metals combined with something. So what we tend to find is we find most of them tend to be something combined with oxygen to form an ion. And so we use this suffix "ate". Now you might have heard your teacher talk about a compound called a carbonate, which means somewhere along the line carbon and oxygen have reacted together in a proportion or a ratio to form an ion. Now, as we know, carbonate is C for carbon, O for oxygen, but there are three oxygens together, and it has a charge on the ion of 2-, and as we saw before, the charge on the ion is also the same as its valency, or its combining power. So carbonate has a 2- charge. Now if we add a hydrogen to that, and we form a hydrogen carbonate, or some teachers might call it a bicarbonate, then we have a HC, then 3 oxygens combined, right? So HCO3, and it's got a charge of -1. So it also has a valency or combining power of 1 this time, and that makes a difference. Other common 8s that we find are nitrates, which is N, combining a nitrogen combining with 3 oxygens to form an ion, and it's NO3. It has a valency of -1, the ion charge is -1, and its valency is 1. Phosphate, which is phosphorus and oxygen. Now in this case we've got 1 phosphorus, we've got 4 oxygens, and the charge on the ion is -3, so the corresponding valency is 3, or combining power is 3. Sulfates, the chief sulfate we deal with is S, sulfur, combined with 4 oxygens, so SO4. It has a charge on the ion of 2-. Notice that all these ones so far have a negative charge, so we treat them as they are non-metal elements. That's the trick when we're actually writing the formula and naming them. The non-metal element, of course, comes last in the name. So sulfate, as I said before, S with 4 oxygens, so SO4. Charge is 2-. That means its combining power is 2, and its valency is 2. Chlorates are chlorines combined with oxygen. Now they've got quite a few of them, and we don't strike as many of them in our early studies of chemistry as we do as, say, in the IB diploma course. But that's another story, and we'll leave that alone for the time being. So we have to remember that when we put these things together, they will act just like as if they were just one element, and they will combine just like they were one element. The only thing we have to remember to do is if there are more than one of them involved in the compound, we must surround them with brackets, and then we have the subscript of the number that are involved. So let's say if there are 2 nitrates involved in a compound, then we would have a bracket, NO3, bracket, and then 2. Now remember, make sure the 2 would be subscript, as is the 3. All the numbers we tend to use in chemistry in formula are subscript. The only time we use a raised or superscript is when we're giving charges on ions, and that's pretty consistent with all of our science and chemistry in particular.